Here we are with Unit 6, Lesson 9, looking for associations. We're going to take a little walk from scatter plots today to look at another way to represent the data that could also be represented by a scatter plot. First thing we're looking at is a notice and wonder. This is called bar association, meaning that we're looking at a bar graph. It says, what do you notice and what do you wonder? Well, first thing I notice is that these labels don't match with these labels. And so I have to wonder with this piece, what does that actually mean? Are they trying to associate watching TV and playing sports? Are they trying to associate watching not much TV? And what actually does not much TV mean? What does watches TV mean? Are you binge watching like right here, 40 hours a week? Or is it 40 minutes? Or is this 10 minutes, 10 shows, 40 shows? There's a lot of information that's missing here. We have a lot of questions we can ask. And I really wonder, why didn't they give me more information? So that's where I'm at with that. I want you to be thinking about your own pieces with that one and see what you can come up with. The next section here is matching representations card sort. I really wish that I could give you the cards so we can actually talk about this, but what we're going to work with is some two-way tables. So these two-way tables, you may have seen something like this before, perhaps not, but here is the first thing that we're looking at. In this two-way table, we're looking at the association between the age of children and whether they have a cell phone and whether they don't have a cell phone. So you have one of the cards that would look like this one right here. I'll get to this part here in a second. But one of the cards would look like this first bar graph down here below. And what we see with this is that we see that this darker color right here has cell phones and that the stripe side has no cell phones. And we might be wondering, well, how am I supposed to read this? I don't see a label here. I don't have a lot of information. But in reality, we do have a lot of information. If you look back at the table, what we do know is this column right here is represented on the x-axis. All of the ages are represented on the x-axis. And when we look at the y-axis, we would have to represent that and recognize that that's a total number of people. It can't be the has cell phones and doesn't have cell phones because those are measured here. This is a total number of people. Okay? Now, with that understanding, I can go ahead and use these data right here to actually understand or to actually interpret what we have here. The first one right here, the first one that has a cell phone between 10 to 12 years old, it might be helpful to go ahead and put a label of 25 right here at the top, and then 35 at the top of the next one. We could do the same thing all the way across. 13 to 15-year-olds, 40 have cell phones, 10 did not. 16 to 18, we had 50, and then 10 that did not. Okay. So those ones are pretty straightforward. They can show just some plain information. And what we can recognize with this is when we add these two values together, they would correspond with the total value here, as well as tell us where at on the y-axis we're actually measuring these values. So 25 and 35 is 60, 40 and 10 is 50, 50 and 10 is 60, just as we see up above. If we added all 6 of these numbers together, we would get 170. When we look at the next one, we see something called a segmented bar graph. Segmented bar graphs, you'll notice that the two categories are stacked on top of each other. And the numbers here on the y-axis are different. What we recognize with the segmented bar graph is segmented bar graphs are measured using percentages. So this would be percent of people that actually have the cell phones. So now we would have to use our other information from up above to be able to determine what percentages actually have and don't have cell phones. We can do that by just taking a simple ratio and saying for 10 to 12-year-olds that have cell phones would be 25 out of 60. That do not have it is 35 out of 60. So we could look at this and say 25 out of 60 have a cell phone, and 35, sorry, that's probably kind of hard to read, out of 60 do not have a cell phone. And so just with a calculator, we can take these values. 35 divided by 60 gives us a percentage. And if we take that percentage and multiply it by 100, or excuse me, gives us a decimal, we multiply by 100, we learn that we have about 58%. So, or 58 and 1/3%, which means that this one down here should give us 41 and 2/3% if we did this right. So 25 divided by 60, there we go. There's our 41.6 repeated. So we could say about 41. We could probably call this one about 42, just to make sure that our numbers do add up to 100. Okay. We can do the same thing for each of these other ones. We have 10 out of 50 for this category. And then we have 40 out of 50 for this category. 40 out of 50 is 80%. 10 out of 50 is 20%. And again, you see the total is 100%. And then on the last one, we have 10 out of 60 and 50 out of 60. I don't know those ones off the top of my head. And it's about 17%. And so 50 divided by 60 should give us the rest of that, about 83%. And there you go. So each of these have good information. We recognize that the bar graphs and the segmented bar graphs have their labels removed. But what we did is looking at this and understanding what the labels are helps us to make sense of what the data are. So a couple different ways of looking at bar graphs, a couple different kinds of bar graphs. And there's information that we can gather from these pieces of information. So since the labels were removed, it was helpful to add those onto it. We saw that putting all the cards in the situation of the same group, we did that. One group does not have a two-way table, make a two-way table for the situation. All these things are things that we could have done with those pieces. So the next section that we're looking at is, well, what do I have when I'm just looking at a table? This is what we call a two-way function table or a two-way frequency table. And what happens with this one is we see the same information. We see the ages of the children, and then we see who has cell phones and who doesn't, all the exact same data. And so when we looked at these pieces and we talked about completing the table with who has cell phones and who doesn't have cell phones, we can look at the totals right here as a relative frequency. Relative frequency means in that frequency, the table, it shows everything as a percentage. Okay. So when we talk about who has a cell phone and who doesn't have a cell phone, we can go back and think about the same things that we just did right here with the segmented bar graph. And then we can represent that same kind of data and determine that same kind of data right here for these values. So we know that the total is always going to be 100% of the population that's surveyed. If I have 42% that have cell phones, then I must have 58% that do not have cell phones, because the total would add up to 100. I can take 100 and subtract 42 and get 58. 13 to 15-year-olds, they didn't give us a lot of information here other than 100%, but we already know what's going on here. We know that 40 out of 50 have cell phones and 10 out of 50 do not. So we can look at that part again. 40 out of 50 is equal to 8/10 or 80%. And then we can look at 10 out of 50 is equal to 20%. And finally, the last one, again, very similar to the first one. 100 minus the 17 that's given gives us 83. And so we have 83% of our students have, or of these children have cell phones in the ages of 16 to 18 years old. So when we look at these two-way tables, it says two-way tables that show relative frequency. Again, relative frequency means not exact value, but really close. Some of these were rounded up. They often don't include a total for the bottom row, meaning right here, how come there's no total down here at the bottom? Well, let's see something interesting. If we take these values and we take these totals, we do 42 plus 80. That automatically is already over 100. We add the other 83%, and now all of a sudden we have 205% that would be represented in this bottom row. That seems kind of silly. We have 58 plus 20 plus 17 gives us only 95%. So it wouldn't be really right to say 205% of these children have cell phones and 95% do not. It is true that all three of them together will add up to the 300%, but the bottom row, the total row, why isn't that included? Well, these values would exceed 100%. And so we have to look at these values a little bit differently than I would any other function table because of the frequency there. It has to add up. If we're talking about a total value with these, we should always have a total of 100%, no matter how it goes. Vertically, we don't add them up, but only horizontally is how these tables work. Is there an association between age and cell phone use? How does the two-way table of relative frequency help us to illustrate this? Well, as we look at these tables, we see that as the cell phone age, or excuse me, as the age increases, we're also seeing an increase of who has cell phones. We're also seeing a decrease in who does not have cell phones. We see a significant jump from 10 to 12 up to 13 to 15, but we don't see such a dramatic jump or decline in either one of these values moving on to the next category. So we definitely see an association here. That association is that older children tend to have more cell phones. Is there association? How does the two-way table or frequency table help illustrate this? As ages increase, number of phones increase, while without phone tends to decrease. There you go. So again, like we talked about, this is really the same way of representing a scatter plot type of data, two different data that have some kind of an association, but we're just representing it, looking at it in a little different way, looking at it from a table perspective, a two-way table. And then we can also look at it in a graphical representation. Now, we don't always do these, are you ready for more? But here's one I think would be an interesting piece. A pollster attends a rally and surveys many of the participants about whether they associate with political party A or political party B, and whether they are for or against Proposition 3.14 or Proposition 314 going in this voting soon. The results are sorted into the table shown. The news station, one news station represents or reports these data by saying a poll shows that the same number of people from both parties are voting against. So we look at this and we see that that's pretty true. 165 for party A, 165 for party B. That's pretty true. A second news station shows this graphic right here, that there were 1,000 people polled in party A, 240 people polled in party B, and we just see some information with for or against. Are either of these reports misleading? Explain your reasoning. Well, I think that this first one is definitely an obvious misleading thing because they didn't say anything about the for type of situation. When you look at this and you look at the relative value of this, 165 out of the total, there's not quite 1,000. Looks like there's probably, let me add these up real quick. There's 997 people, and 165 out of 997 people is just 16.5%. So when we talk about this up here, just 16.5% are for the value. When we look at the property B, it says against, we see that 160 out of 240 are against it. And then when you look at that piece of 160 divided by 240, we see that that's about 67%. I'd say there's very much a big discrepancy. Party B is definitely against Proposition 314. But Party A is definitely not, as a larger party goes. The next one, we talked about this frequency table down here. We see that this is a segmented frequency, which means that these are actually measured by a percentage. And so as a segmented frequency, this is also misleading, because what we're suggesting here is that Party A is very much for it, that very few people in Party B are for it. We can see a little more clearly about there, but we still see a relatively equal amount for against. So with this one, it's kind of misleading, stating that there's a large percentage for it. It is a little bit easier to read to say that that there's more people that are for the value. It's a little easier to recognize who's against it, but it still doesn't quite do the justice that we need to be able to understand that this is 16.5%. And really the big reason is because of the numbers on the side. Out of 1,000 people, it gives it the illusion that there's more people that are in one category than another. So how would you actually talk about this? Well, if we were going to recognize this, there is one question on the next page. It says, create a headline graphic or short description that more accurately represents this. Party A is heavily in favor of Prop 314, while Party B is heavily against it. Okay, that'd be a lot more accurate than the other. And that brings us to the end where we have our summary. When we collect data by counting things in various categories like red, blue, yellow, green, whatever it may be, we take this as categorical data. Okay, and we have a categorical variable. So it's a little bit different than what we did in the previous one. We can use two-way tables to be able to investigate connections, possible connections between the categorical variables, just like we do with scatter plots. In this case, in this example, here's another table that talks about studying. It's the results of a study of meditation in athletes before a track meet. And we talked about these people that meditated versus did not meditate. There were 53 people that stated that they were calm, 44 that were agitated, total of 97 people. This is really an important piece right here, because the total, 97, represents the entire group. You'll notice that this final category down here also represents a total of the values above and the total of the values above. And these totals represent the inner pieces as well. So when we look at a two-way table, we really have to look at how is everything listed. This one's a little different than what we saw with the segmented bar graph, because this total is representing the bottom. We can't do that with the segmented bar graph. So if we're really interested in questions of whether things are associated or not, like with this one, meditating and being calm, we might represent the frequencies in a bar graph. We might group the data about meditators and non-meditators so we can compare the numbers of calm and agitated athletes in the group. We would probably not use a segmented bar graph necessarily to represent the whole situation, unless we took out a bottom section right here and changed the data just a little bit to represent percentages, or to more readily accommodate for that percentage value. So that's a little bit about two-way tables. Thanks for checking in. Thanks for working with me on this. Hopefully you got something great out of it. If you have more questions or some concerns about the lesson, please feel free to email me, reach out, and we'll see you in the homework help. Have a great day.